welcome to the next talk. Megan is going to talk about DeepNote and Snowpark. All right, go for it.
Hi everybody, thanks for joining me during what should be lunchtime, so I appreciate you guys foregoing that. Hopefully you can grab some bites afterward. My name is Megan, and today I'll be talking about using DeepNote and Snowpark together. Quick show of hands, who here has used Snowpark? Okay, so like 3. Who here has ever used or heard of DeepNote? Oh nice, wow, that's surprising, awesome, okay cool. I will have to report those stats back. So, the goals today are to answer what is DeepNote, what is Snowpark, and how do they work together, so that hopefully by the end of this, we have more hands raised for both what is Snowpark and what is DeepNote. And along the way, we will be doing the following to get to know these tools better. We'll be uploading sample data into Snowflake, performing in-warehouse data transformations, and then deploying a machine learning model at the end to do some churn prediction. A little bit about me. I am a new data advocate at DeepNote. I've been here for about 2 months. I was previously a data scientist at another small data vendor startup called Narrator, where I was responsible for building advanced analytics tooling for data analysts and data scientists. Okay, a little bit about me. I am a SQL lover at heart. That is actually a neon sign that I custom made and hung up in the corner of my room. And yeah, I just love SQL. But as we all know, it's a little bit limited in its data processing capabilities, especially when it comes to use cases like machine learning modeling. So from working with a lot of data scientists and machine learning teams at DeepNote and at Narrator, I learned that there are a lot of different tools, languages, environments used for getting machine learning models into production, and not to mention the fact that a lot of the data sets that are involved have to be moved back and forth between client side and server side in the process. So how do we cut down on that complexity while still being able to work with the tools that we love? For me, I wanted to find libraries and environments that allowed me to use the best of both worlds when it comes to SQL and Python to build those robust pipelines needed for deploying experiments and pipelines into production. And this is where DeepNote and Snowpark come into play. DeepNote is a cloud-based data science notebook that allows you to streamline EDA and data science workflows by giving you access to Python, SQL, and visualization blocks all in one tool. Snowpark, on the other hand, simplifies the process of building complex data pipelines and allows you to interact with Snowflake directly without having to move data to the system where your application code runs. And they're both great individually, but together they make the warehouse feel like an in-memory object that is ready for rapid data exploration. And this is the roadmap that we will be going through today. We'll first load our data, perform some transformations on it to then arrive at a staging version of it, use that to create fact and dimension tables, which then serve as the basis for the data set that we will be using for model training and prediction. And then finally, we will be deploying that to Snowflake. Let's go here. All right. So the first step is to set up Snowflake so that we can bring in our raw data. The raw data that I will be working with today is a telecommunications data, probably something that some of you have dealt with, where there are 100,000 records of telecom data. But to do that, we first need to create the session object. And this session object accepts SQL. So we'll use that to create and interact directly with our Snowflake warehouse. And that is where we will be uploading our telecom data to create a new table that we'll stage. I wanted to call out this special method called Snowflake con prop. That is used to configure our environment to use our Snowflake credentials. So this is the step where we're using SQL to create the database in the warehouse. And now let's see. This is the data that we have loaded into our table. And we can do that, we can display the data that we've loaded using two very Pythonic methods that are available in Snowpark's Python API. So you'll see I'm using this .sample and the .toPandas methods, which make it very familiar for Python users to interact with the Python API. So that is a quick sample of the data that we have loaded into Snowflake. Okay, and so now that we have uploaded that data, we are going to start transforming it. And we'll be using the DataFrame API available in Snowpark to do that and create new tables out of it. And so you'll see these are the 4 different tables that we will create from that raw data. Okay, so we'll create demographics, location, status, and services tables out of it. So first, in the location table, I wanted to call out some methods that make it very, for SQL and Python users to be very familiar with working with this API, such as this .select method, these call methods to pull out specific columns, and as well as using aliasing and naming methods to rename some of the columns to do that basic data cleaning. Next, in the demographics table, you'll see that I'm using this if method, and that is used to do some more cleaning to replace all instances of the letter M with the word male. Status table, doing some of those similar things, as well as with services table. With the services table, we're filling a lot of those null columns. And so once we have created all of those fact and dimension tables, this is where the fun really begins, and we're creating the telco data set that will be used to build our models. And that comes from joining the demographics and services tables together. And you can see here, this .join method does that. And something to call out with the Snowpark API is that Snowflake already disambiguates the field that it was joined on. So you see this customer ID and then this other customer ID column. So to easily handle these duplicate columns, we can use some basic drop methods. And then once that is cleaned, we'll save it as our new telco data set. So now we have finished this first step of creating our staging table. And the first real fun step is performing the EDA step. Exploratory data analysis is done really easily in Deep Note. And this is what we'll be walking through here. So how I will be doing the exploratory data analysis step is by taking a sample of rows from the newly created telco dataset table to use for training, and then converting that into a training set using Pandas DataFrame for easier EDA done in Deep Note. So I'm defining that sample here, and let's take a look at that data, or that sample data that we will be exploring further. And where Deep Note really shines to be able to enable you to do that EDA is that immediately when you, this DataFrame viewer allows you to easily see stats about the variables. So you see the breakdown of the different values in a variable. And then, let's see, what else is there? You can also apply filters here so that you can handle the data more easily and understand some relationships that might drive some of the future predictions that we'll be making. And lastly, you'll see here that we have no-code visualization blocks that you can use on top of your matplotlibs and your plotlies, all without the need to code. And so those three things, so the data frame, viewer, the filters, and then the no-code charts really allow people of all different skill sets to get an understanding and explore their data and really break down those barriers that arise when, say, like you're working with teammates who have different coding abilities than you do. And so we're done with the exploratory data analysis step, and then we can begin the training step here. Let's see, okay. In the training step, we'll be fitting a random forest model to our data, and then evaluating that performance by looking at its balanced accuracy, since the target variable is not evenly distributed. So that's what we're doing here. And the balanced accuracy is 98%. And then also we'll be looking at the accuracy of the classification. And if you recall, our goal after exploring and training the data set is to actually deploy the model in Snowflake. And so that is what we'll be doing here. And one other special feature about Snowpark that I want to call out are these user-defined functions. These are functions that are defined in Python or from a Lambda, but they run on Snowflake compute. And so these are perfect to use on our newly created model that we want to move to the Snowflake server, where that will be used to create predictions later. And so here, let's explore some of those UDFs that we're creating. So once I've grabbed the sample from our telco data set, we're going to use this UDF model.predict on each row in the Snowflake server. And then those new predictions are written to a new table in the warehouse called churn detection, which you see here. We're saving that new table as churn detection. So when we take a look at this new churn detection table, we can see the actual versus predicted churn values, which are going to be saved in the warehouse without data ever needing to be moved out of it. And so that saves on a lot of compute, saves on a lot of time, and that is really the main benefit of Snowpark. And yeah, so that is the finalized churn detection table that lives inside your Snowflake instance. And let's go back to what we have accomplished. Okay, so we, after we loaded the data into Snowflake, we performed some exploratory data analysis steps using Deep Note. We then performed some model training again in Deep Note, and then we were able to deploy it to Snowflake using Snowpark's user-defined functions. And so hopefully at the end of this tutorial, and I'm happy to share these slides so that you can go through it in more depth, we have accomplished 5 things. We've moved data from Deep Note to Snowflake. We use the Python API available in Snowpark to transform raw data into a data science-ready table. We performed EDA, trained and evaluated a churn prediction model all within Deep Note, deployed that model to Snowflake, and we're able to now predict churn without moving data out of the warehouse. And then we're also able to return new predictions within that warehouse and save on a lot of time compared to if you had to move it to your application where you're doing your coding. And that's it.
Let's thank our speaker. Any questions?
Yes.
So for the visualization, of the training step, I'm just curious if you'd be able to push the compute for those steps down into Snowflake as well, or is that something you have to pull the data back for?
I believe you can. There are, so with Snowpark, you have definitely pandas, NumPy, all of the basic packages available to you from that Python API to do that all within the warehouse. But with by pulling it to deep note, I was just trying to demonstrate the ability to use the no-code blocks. But certainly if you're more familiar with like Plotly, Matplotlib, you can use Snowpark to do that all within the warehouse.
Great.
Any other questions?
Yeah, thanks for that talk, Megan. Can you talk to us a little bit about, I guess, what the efficiencies of having this, being able to move this data around like this looks like for us at scale?
Good question. I would, so.
But what about collaboratively? Like, does this help because I can like send this data to not just like my data engineers, but also to like data analysts, data scientists, software engineers, like a larger group of people?
Yeah, so by consolidating this workflow into just like one or two simple pipelines, there are definitely collaborative advantages to that, because if you were to have the data set move to multiple sources using multiple tools, you're going to have multiple hands on all of those different tools and those pipelines. So just by consolidating it to fewer destinations for your data, you will have less hands on it, but it's easy with Deep Note especially to document and to document those workflows, how you're performing it, and share it with your collaborators. And also with Deep Note, you can have multiple people work in your notebook, this cloud-based notebook, at the same time. So you don't have to export those workflows to multiple places. You have it in Snowpark and just in Deep Note, and everybody has transparency on that pipeline there.
Thank you. So are there any things in the pipeline or any tools that you know that are available for incorporating this sort of efficiencies into like BigQuery or other kind of warehouse methodologies in the cloud? Or is this just like specific to like Snowflake or, yeah.
Yeah, that's a good question. As far as I know, obviously Snowpark is native to Snowflake, but I would imagine, so Snowpark has been released for like a little bit over a year, and so our teams have seen a lot of advantages from using Snowpark, and so I would imagine like the BigQueries, the Redshifts, they would release something similar, although this is still kind of new. But yeah, for us it's had a lot of advantages, so I would imagine the other big warehouse providers would capitalize on that.
Any other questions?
Thank you. Yeah, I was wondering, does Snowpark have any ML ops built into it within like retraining the model or adding features, stuff like that?
I would imagine so. I am not completely sure. I can get back to you on that.
Thank you.
Thanks for the talk. Question on like the transformation steps. A lot of it looks super similar to like what I've done in PySpark or Spark. Is there like a SQL equivalent where I could just pass SQL statements instead of doing like select and then call wrappers or whatever? Only because I feel like the call wrappers are super annoying for me.
Yeah. Let me see.
Or I could do like snowpark.sql and do whatever SQL statement I want.
There was. Hold on.
I think there was definitely stuff later on where it's like you're creating a table where.
Yes. Yes.
Oh yes, this is great. Okay, cool. This is great. I love this. I just don't. I don't. It seems very verbose to type call whatever.
Yeah. So the beauty is that you can work with Java, you can work with Python, you can work with SQL in Snowpark. So it gives the developer the power to choose the tool that they want to, and so that's why I like using it, to combine SQL where I want to use it and then Python where I want to use it.
Yeah, because especially because if you're trying to like drop a column, you don't want to like. If you're writing in SQL, it's not really a drop column. It's like select all these things all over again except for this one.
Right. Yeah. So in some cases, some use cases, Python's easier, and then other use cases, SQL's easier. So that's the beauty of Snowpark, allowing you to use the tools where you want them.
Awesome, thank you.
Any other questions? No, another one.
Okay, does this mean I can connect like multiple, like, is it easy to connect like multiple data sources into Snowpark? Is this one of like the advantages that comes with it? And then what kind of data connectors can I add to it?
I can definitely speak on the deep note side. You can connect CSV files, right? But you can also connect all your different warehouses and like if there are APIs to other apps like that, you can bring it in there. I would imagine for Snowpark, it's whatever connectors you have to Snowflake that will trickle down into Snowpark.
Okay, let's thank the speaker.